So we left off on the biconditional. All right, good. So we got a few more things to talk about before we actually get into something that you recognize as geometry, like points, lines, and planes, triangles, all those pretty lovely pictures. Because remember, we're talking about proofs, we're talking about logic. We got to get that first. So the first thing we need to talk about here is the difference between a proof and a conjecture. So remember, a proof is this long list of statements and justifications. All right, it's just like one long argument. It's not like in the real world. In the real world, we think of proof as evidence. It's not like that. In geometry, in any other branch of math, proof is a long list of statements and justifications. It's one long argument. Now, there's something called a conjecture, so I want to talk to you about that one. A conjecture is basically a best guess. All right, it's your best guess. That's what a conjecture is. So let's see here. So a conjecture and I'm going to say an educated guess. Conjecture is an educated guess. All right, so conjecture is an educated guess. Now, I'm going to give you an example of a conjecture. Suppose we talk about how about adding consecutive numbers? How about consecutive whole numbers? So let's add three of them together. So 1 plus 2 plus 3. All right, so I have three consecutive whole numbers. All right, 1 plus 2 plus 3, which of course equals 6. Now let's see what happens if I add another three consecutive numbers. Let's just start with the 2. So 2 plus 3 plus 4. If I add that together, I get 9. Let's go with something a little higher. How about we'll start with 5. So 5 plus 6 plus 7. Now, of course, that's going to equal 18. Now, do you see the pattern? Don't be afraid to pause the video. Because think about it. What's the pattern here? There is a pattern. And the pattern is that all of these are divisible by 3. 3 will go into each one of these. 3 goes into 6, it goes into 9, it goes into 18. So in this case, for this example here, so I'm looking at these numbers here. My conjecture, so I'd say I conjecture that the sum of all 3 consecutive whole numbers are divisible by 3. Divisible by 3. All right, so I conjecture that the sum of all 3 consecutive whole numbers are divisible by 3. All right, so that looks good. Now, the thing about a conjecture is that I can fill my whole page up with examples like this. I could start with 5. I could do 1000, 1001, and 1002. I can fill an entire book, not just a page, but an entire book of examples, but that's still not a proof. Again, proofs have to be precise, because once you prove something, it's always true. So that's the question then. How do you prove this? What's the difference between proof and conjecture? So the conjecture is I'm just making a guess based on a pattern that I notice. Proof is literally proving that this works. If I do a proof, it tells me that I can do this for whatever 3 consecutive whole numbers that I want to. I don't even have to try it. I don't even have to test it. I will automatically know that it's going to work. That's a proof. That's called deductive reasoning. So deductive reasoning is what we want to do. So deductive reasoning, let me write that down. Deductive reasoning. Deductive reasoning, that is a conclusion based on logic. So I could say a conclusion argument. So a conclusion slash argument based on logic. Now, the opposite of deductive reasoning is inductive reasoning. So, inductive reasoning. See if I have enough room there. Inductive reasoning. Conclusion argument. So, conclusion, or you can call it an argument. But this is based on examples. So in this case, my conjecture here is inductive. It's inductive because I'm basing it on examples. I wrote out some examples and I noticed a pattern. Okay, that's inductive reasoning. Now for a proof, I want to get into deductive reasoning. And there is something called proof by induction, but I'm not going to show that to you. You will thank me, believe me, when you get to it. You'll be glad I didn't show it to you. But in general, what we're worried about is deductive reasoning. That's what proofs are about. Proofs use deductive reasoning. They are based on logic. So the conjecture, I can use inductive reasoning and say, hey, something's going on. But ultimately, to prove it, I need deductive reasoning. So, all right. So that's my conjecture. Now, I can write this out. So let's use a little bit of algebra here. Let's use a variable. If I want to represent the sum of three numbers, so I would have three consecutive whole numbers. I would have n plus n plus 1 plus n plus 2. So for example, if n is 1, I would have 1, then 1 plus 1 is 2, and then I would have 1 plus 2 is 3. So I'd have 1, 2, 3. Right? So I can represent any three consecutive whole numbers using this right here. And you always define it. What is n? Always define it. Because I don't know what n is. You have to tell me. Let's say where n is a whole number. Always, when you bring in a variable, always tell me what it is. Unfortunately for you guys, we're not going to be using a whole lot. I mean, this is like a lot of number theory, really. Ours is a little different geometry. The terms are going to be a little bit different, but this is the same building block, and sometimes you will have to do this. So even for you guys, it's important. Anytime you introduce a variable, always say what it is. It's an angle. What kind of number can it be? That kind of thing. Okay, so let's see here. So the sum. Well, the sum, let's add them together. So I got 1, 2, 3n. So the sum is 3n. 1 plus 2 is 3. And for my reason here, I'm just going to say property of addition. If I can fit it in there. So that is the property of addition. That's my reasoning. Every time you give a statement, you got to give a reason or a justification. All right, now, so I got 3n plus 3. This is actually looking pretty good. 3n plus 3. I can factor out a 3. You guys have had algebra. You should know this. So I can factor out a 3. And I can verify it. 3 times n is going to be 3n. That's my first term. 3 times 1 is going to be 3. That's my second term. All right, this all checks out. I'm going to say distributive property. Okay, so that's distributive property. And now, okay, so the sum, and I don't know if you see this or not, the sum is divisible by 3. I'm just going to say property of division. But let me show you where I get this from. So I say that this is divisible by 3. So this right here, this is divisible by 3. Let me show you, let me kind of move over and show you what I mean. So I have, when I say this right here is divisible by 3, I mean if I divide it by 3, that's what I mean divisible by 3. But look at what happens. 3 over 3. Well, guess what? That cancels out, right? So I'm going to get a whole number. N is a whole number. If you add 1 to any whole number, you're still going to get a whole number. Add 1 to 5, you're going to get 6. Add 1 to 1,000, you get 1,001. You still have a whole number. All right, so this cancels out, and I'm just left with a whole number. So this term is divisible by 3. If I had a term like this, let's say, I don't know, 7 times n plus 1. Well, if you can get it like that, then yeah, it's divisible by 7. Is it divisible by 3? No. I can cancel out the 7s. But if I had 7 times n plus 1 divided by 3, well, I can't cancel that because these two are completely different. All right, so that won't work. So hopefully you can see now what I mean by divisible by 3. So with the proof is all this stuff right here. Let me try and get this in the window. The proof is this stuff right here. First, I have to state what it is that I'm proving. So I'd say the sum of all 3 consecutive whole numbers are divisible by 3. So that's where I'd start. The sum of all divisible consecutive whole numbers are divisible by 3. All right? And you could say, if we want to tighten it up, we could say let. People like to use the word let in proofs. If you want to introduce something into a proof, you say let. So let the sum be. So let the sum be n plus 1 plus n plus 2, where n is a whole number. Great. The sum is 3n plus 3, property of addition. Great. 3n plus 3 equals 3 times n plus 1, distributive property. Great. The sum is divisible by 3, property of division. So we have proved it. And you want to make sure that your last line basically says the same thing as the first line. So if I want to be more specific here, I say, therefore, the sum is divisible by 3. So therefore, the sum is divisible by 3. Or therefore, the sum of 3 consecutive whole numbers are divisible by 3. And this is my advice to you on a proof. You can never write too much. All right? I'm going to say it again. With a proof, you can never write too much. I'm going to write it down too. Proof. You can never write too much. Because that's the mistake people make. They don't write enough. So, you can never write too much on a proof. All right, very quickly here, let me get talk about proof by contradiction. All right, so I'm going to save that for the next video, actually. I'm not sure how we are on time. I'm afraid we're over time on this video. But before I sign off on this video, I need you guys to copy this down. This is going to give the properties. These are things like, remember when I said when you do a proof, you're going to have a list of statements. Each statement has a justification. Well, these are the justifications that you can use. So it's important to actually have those with you. See if I can get everything in here. It doesn't want me to for some reason. I don't know why. Nope. There we go. All right. So these are properties of equality. These are the kind of statements. So whenever you make a statement, you always need a reason. So whenever you make a statement like one of these, this other column is going to be your reasons. These are going to be your justifications. All right. So, you know, if I say like x equals y, well, then y equals x. Well, then I'm going to say symmetric property of equality. All right. Really, the last 4 are the most important ones. So just pause the video, write it down, and that's the end of the video. All I need you to do is write this down, just go on to the next video. So just write these down, pause it, and I'm going to move this around in case it's too small for you to see on your screen. Otherwise, just write them down, you're fine. See if I can't get a better view here. All right, so this would be, these are the first ones. You can't see those. Okay, pause it. Good. Move my finger. These are the last ones. You need it, pause it. All right, so I'm going to go ahead and move on to the next video.